All right, so we're taking a look at the derivation for the product of two functions, or sorry, the derivative of the product of two functions. So we saw that it doesn't actually work out to just go ahead and take the derivative of each of the functions individually and multiply it together. So let's take a look at what actually does work. So let's say we have a function which is the product of two other functions, called f of x and g of x. Okay? So if we do the derivative of this thing, now we're just going to work kind of backwards here. So I'm going to kind of reveal what's happening here, but we're going to see that this is the same thing as f prime of x times g of x plus f of x times g prime of x. Okay, so this is the rule that we're actually going to get to. So we're going to use this as a guide to getting to there. Now, we're looking at this thing here. You can see that f prime of x is the same thing as the limit as h goes to 0 for f of x plus h minus f of x over h. Right? Same kind of deal over here. You see that the limit as h goes to 0 for g of x plus h minus g of x over h is the limit definition for the derivative of g of x. Okay? So with that in mind, what we want to do here is if we go through and look at f prime of x, that's going to be the same thing as the limit as h goes to 0, and since it's f of x times g of x, it would be f of x plus h times g of x plus h, right, minus f of x times g of x, all over h. So what we want to do is we want to go ahead and bring in some pieces of information, or make some rearrangements, bring in stuff, so that we end up with those two limits as parts of our new limit down at the bottom. So as I'm looking at this thing here, I already have a, let's say, if we look at this thing here, we can see that right here we have a g of x plus h, and I have a g of x over here. Right? So I want to go ahead and rearrange, and I also have an f of x plus h and a minus f of x, but I can't really factor this thing as it is. Right? So this is where the interesting part of this derivation comes from. I'm going to go ahead and introduce a couple of things in here. Right? So I have f of x plus h times g of x plus h. Nothing new there. But what I'm going to do here is I'm going to introduce some stuff into here that would be helpful. And what I mean by that is, if I introduce a, let's see, we'll do a minus f of x plus h times g of x. Now, I'm introducing that because if I factor out an f of x plus h, I'm left with g of x plus h minus g of x, which would get me to that limit definition I have up on the right up there. But I can't just add in something that's convenient. That would completely throw us off. But here's the interesting piece. I'm going to go ahead and add in f of x plus h times g of x. So effectively, I'm adding 0 to this thing. So it doesn't actually change the overall value of this fraction, which is pretty cool. And then I'll have still the minus f of x times g of x that was already there. Now keep in mind, this whole thing is all still over h. Right? So now as I take a look at this thing and I rearrange a couple of things, I can see that I have the limit as h goes to 0. Notice I'm keeping that limit notation all the way through. But I'm going to factor out an f of x plus h. Right? And when I do that, I'm left over with g of x plus h minus g of x. And I'm going to do the same thing with the other one. Here I'm going to go ahead and factor out a g of x from it, from both of the second two terms there. So if I pull out a g of x, I'm now left with f of x plus h minus f of x. Okay. Still all over h. Right? And so now as I take a look at this, remember you can split things up in terms of limits. So I want it to look like what I have up here at the top. So if I go ahead here, I can see that if I rearrange a couple of things here, this is the same thing as the limit as h goes to 0 there, goes to 0 of f of x plus h. Right? I can leave it like that. I could do times, and then I have g of x plus h minus g of x. all over h. So I can set it up like that, right? Do the same thing over here, the limit as h goes to 0, and here I can do it of g of x times f of x plus h minus f of x, and that's over h also. Right, so now that I have this thing set up, I can see that if I look at this, I can see that this, I guess we do one more step here. It might seem a little bit much, but let's go ahead and split up the product here so it looks a little more neat, I guess. It's over h. So now it definitely looks like the derivative of g of x, right? And I can see this one, as I go and rearrange this, I have g of x times the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay. So now, hopefully it's a little more obvious, but if I go ahead and plug in 0 into the first factor on the left-hand side there, I'm just going to end up with f of x. Okay. But now I know that the next piece, next factor, is the same thing as g prime of x, the limit definition of the derivative, plus over here I'll just have g of x. I'm going to plug in 0 into that, doesn't do anything. So just g of x. And then I'm left with f prime of x. Okay. So it's not quite the same arrangement that I have at the top, but remember, addition is commutative, so you can switch things around. And you can do it as f prime of x times g of x plus f of x times g prime of x. Okay. Either version is fine, but that is the product rule. All right, hope this helps.